Hello, in example 6, we're going to find the integral of 4 over x dx from 3 to 10. So we're looking at this function 4 over x from 3 to 10. If you were to graph this, you would see it is a function that in red here looks like this. And you can see that if we go from x equals 3 over to x equals 10, this green shaded area, which is all above the x-axis and therefore all positive area, this green area is equal to whatever numerical value we get out of here. So when we look at this function, one way to think about this is to think about the 4 as a constant multiplier k. So this constant multiplier k, 4, can come out front and sit in front of the integral of 1 over x, right? So if we think about it this way, 4 times 1 over x is the same thing as 4 over x. So the 4 can come out front, and then I just have to worry about the integral of 1 over x. Now, the reason I did that is because I know that there's a rule for integrals that says that the integral of 1 over x is equal to the natural log of the absolute value of x. Remember, taking derivatives, if I take the derivative of the natural log, I get 1 over x. Therefore, the antiderivative, the opposite of the derivative of 1 over x, is the natural log. So the only thing we have to keep in mind here is that the rule says to take the absolute value of that number. So we're going to put the absolute value symbols there, and we're going to evaluate that from 3 to 10. And we're going to do that for the antiderivative, the natural log of x function. And then when we're done, we're going to multiply the result by 4. So when we do that, we'll keep the 4 outside. We evaluate the antiderivative at 10, so the natural log of the absolute value of 10, minus, we always subtract with the fundamental theorem of calculus, the natural log at the lower limit of integrations, so the natural log of 3. Now, in this particular example, because both 3 and 10 were positive, the absolute value of 10 is just 10, and the absolute value of 3 is just 3. So it doesn't really play much of a role here. If either of these were negative, then it would affect the value of what we get when we took the natural log. So I just put this on my calculator. The natural log of 10 minus the natural log of 3 goes in first by order of operations. We do what's inside the parentheses. We get some result. Don't clear it out. Just find an answer for these two things, and then multiply by 4, and you get 4.81589. And so this represents the area that is shaded in green right here between x equals 3 on the x-axis and x equals 10. So there's an example of not only finding the antiderivative of 1 over x to natural log, but also where moving that constant multiplier out in front is really handy, because it allows you to see that, oh, I'm just taking the integral of 1 over x, which I know is the natural log. And so I'm rewriting this function in a different form so I can apply a simple and well-known rule to that integral.